Hi and welcome. My name is Bob Divner, Senior Applications Engineer at Corelis. In this presentation, I'll be showcasing ScanExpress ADO software, our Advanced Diagnostics Option for ScanExpress Runner. ADO provides pin and net level diagnostics for clear, concise information, either as human-readable text or highlighted on CAD data with the optional ScanExpress Viewer integration. Let's get started. The basic diagnostic system in Runner is expected and actual patterns. So here we have the truth table diagnostics. We have two nets being displayed, databus_1 and databus_2. Our vectors are going to be columns, so each column in that test vector table is a set of signal states. Notice that each net can have multiple pins and each pin can have multiple boundary scan cells. So each row is a boundary scan cell. Our convention I mentioned earlier is 0, 1, and Z are output, LH and X are input. So what we're seeing here, for example, let me turn on my little pointer. So if we look at data bus 1, we see data bus 1 U5.22 is output 0, 0, 1, 0, 1, 1, 1, 1, and so on. All of these other pins are input. So we're expecting to see logic low, logic low, logic high, logic low, but in actuality, we're seeing logic low, logic low, logic low again, and then logic low. Mismatches will be highlighted in yellow with red text to tell you that it was not a match. If you have experience with this kind of thing, you can read this and determine the fault. So what I can see is it looks like I'm getting the same result on data bus 1 as I am on data bus 2. So in other words, where I see low, 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 highs, highs, it looks like they have matching patterns. So I can, as a human being with a brain, I can look at this, I can determine that those are matching patterns, and I can actually look, and I suspect this is a wired and or function. So when U522 is 0, when U523 is 1, we get low. When U522 is low, 1, low. What I'm seeing is if either one of these is low, then they're both low. And I determine, based on that, likely short between data bus 1 and data bus 2. The software can do that too. It can do it better than I can. It can do it much faster than I can. But you do have to have the Advanced Diagnostics Option. That is a separate license from ScanExpress Runner. But when you have that, it will tell you likely bridging fault, data bus 1, data bus 2. So that's number 1. It will call out the nets that are likely part of the problem. It will call out the most likely pins based on proximity. This is the proximity diagnostics. It will say, for example, this is numeric, but so U522 is adjacent to U523. It's most likely that a bridging fault is going to be between two adjacent pins, right? It would be very unlikely. Let me pull up my little demo board. And we can actually look at this a little bit. It would be very unlikely that pin 22 on U5, which is U5, the device under the ribbon cable, is shorted to a pin on U1, because U1 is all the way across the board. They're very far apart. So you wouldn't really expect that short. But what you might expect is this package, this TQFP package, maybe you got a little extra solder between two of these pins, between pin 22 and 23. And based on that, we recommend that you take a look at it. Maybe you put it under a microscope, maybe you grab a logic probe and poke around. Maybe grab a DMM and buzz it out to see if you have continuity where you shouldn't. But that's what that's trying to tell you, is these are most likely the most likely faults. And once you've exhausted that, then you go down to the entire fault list and use that to determine any other likely problems. You know, you maybe start poking around, you see that you didn't test U118, but that is a possibility. Thanks for watching. For more information, visit our website at Corelis.com.